For this unit is kind of taking everything that we've done and now putting it in context of some actual applications. Okay, so this is your growth law right here. Sometimes it's called the decay law, but it's an exponential function. Okay, this n naught is your initial amount. Okay. This k up here, that's your growth or decay constant, depending on what's happening. If things are growing and we get more and more, then it's a growth constant. If things are disappearing and there's less and less as time goes on, then it's a decay constant. And here's how we know which one it's going to be. If we have a positive number there for our k, then it's a growth function. If this is a negative value up here in the constant, then it's going to be a decay function. Okay? And this is pretty straightforward right here. This t, well, that's just time. Okay? And so basically with this growth law, and we're only going to do this growth law. We're not going to really do all the other applications. But just so you know, there's a bunch of other ones like Newton's law of cooling, logistic growth and decay, which is a much more advanced growth and decay model. But this one's a very nice and simple model to work with that works for a lot of applications. Okay, so we're going to work through first example and probably the second and third one, and then that's going to be pretty much it. Okay, so let's look at this function here. That was nice of them. They gave you the formula. Can you guys see that? Okay. Well, you got it in front of you, right? 500 e to the 0.06t. Okay. And so this one, let's just kind of work with plugging everything in and figuring out what we need to figure out. Right? How do I figure out how many insects there are at the very beginning when t equals 0? You just plug it in. So 500 e to the 0.06 times 0. Okay. And you should see something happen. What's this going to be? Yeah, because that's a 0. E to the 0 is 1. 500 times 1 is 500. Now, did we have to do that? Where do we see the initial value in our formula? Yeah, this is always the starting value, the initial amount. Okay? So if you remember that, you could just say 500. I don't need to see you plug it in. If you plug it in, you'll get the same thing, and it's not too hard. Okay? The growth rates. What is that? Where in the formula is the growth k? The growth rate. Yeah, right here, 0.06. Okay? Make sense so far? Right? Nothing too fancy here. What is the population after 10 days? Well, now we do have to plug it in. E to the 0.06 times 10. Okay, let's do that real quick and see what we're getting. What are you guys getting for that value now? Anybody have it yet? 900.
11.06.
So about 911. Okay. Just make sure. No, I do. But in case you are not getting it, some people might be shy to ask. You got to make sure that 11 is in the, or not that 11, that 10 is in the exponent. Okay. Some of you have the nice fancy OS that makes it an exponent. If you don't, and you see this is why I wanted to talk about it. Get out of there.
You tried to do this last time and it didn't work.
Oh, that's right. Well, if you see 500E and then caret, like this, and then your calculator's waiting for you to type it in, you got to make sure that all of the 0.06 times 10 is in the parentheses if you don't have that feature on your calculator. Okay? All right.
Isn't it better to just update the system then? So
yeah, I mean, it's easier because then.
I did that too. Like I had 4 of them.
But now you're good, right? Now you won't make that mistake.
Yeah.
Right? Okay. Problem D. Let's see what happens now. This hasn't been too hard, right? We're just plugging things in and nothing too bad. When will the population reach 650? So now my final population is 650. And then that's going to be 500e to the 0.06t. And so now what I want to do, if they're asking me when, we're looking for t, the time. Does that make sense? How can I get started? What can I do first? Divide by 500 sounds like a plan. Does that reduce to anything? 13 over 10. Okay? Switch it. Yeah, that's why we spend all that time doing log stuff, right? If I switch it, what log base is this? E of perfect. Okay? And log base E, you can leave it that way, I don't care, but if you're lazy like me, just remember that it's natural log ln, right? And now what's the last step to find t? Divide by 0.06. So type that into the calculator, and what do we get? It's got to be less than 10 days, since after 10 there's over 900 already, right? 4.37. Is everybody getting that? Okay. Why don't you guys try E on your own? How long, when will the population double now? Double from the initial amount, yes. Bless you. When you're done, look up. Right now I'm slowly going through each step. So if you're stuck, maybe you can see where to go next. If you're almost done, keep working. What did you guys get? 11.55?
Yep.
Okay. That's what I'm getting. Here are the steps in case you forgot. 1,000 equals 500 e to the 0.06t, because we want to end with double, so that's got to be 1,000 now. Divide by 500 first, so now it's 2 equals e to the 0.06t. Switch it to log form, so it's natural log of 2 equals 0.06t, and then just divide. Okay? Any questions on that?
So the E is the base.
Yes,
The
exactly.
let's choose the argument.
That is correct. Okay, let's turn the page. This is when it gets a little bit trickier, but you guys know how to solve basic exponential and log equations, so I think we'll be fine. It's just you kind of have to split it up and break it up in the steps here. Okay. So for problem 2, notice they didn't give us the formula like they did last time. We got to find the formula. Okay. So population of a colony of mosquitoes, again, obeys the growth law. There are initially 1,000 mosquitoes, and then after 1 day, we have 1,200. Okay? So we have P equals what? 1,000 e to the, do we know K? So we have to figure out K first. Okay? So here's where we start. Now they told us some information right here. After 1 day, the population is now 1,200. So that means I can set up an equation. P would be 1,200. K I don't know, but T is now 1. Okay? So basically it's this equation. How do I solve for K? Before I switch, divide by 1,000. That should reduce to 6/5, right? 6/5 equals e to the k. And now? Now we switch it, right? So log base e of 6/5 equals k. Or natural log of 6/5 equals k. Now sometimes if we had like they might give us, actually we'll just do that in a little bit here, but this is not always going to be a 1. That'll be different from problem to problem. Okay, so that'll come into play later on. Now once you have this, okay, here's my advice, because we want to know what that growth rate is. Natural log of 6/5 is about 0.18, okay? But when we do this problem, okay, we don't want to use 0.18. Here it was 0.06, right? We don't want to use 0.18 in that spot. We want to use everything, okay? So yes, there you go. We're going to store this so that we don't have to like type in all the decimals over and over again, okay? So once you know what this is, natural log of 6/5, you go to the store button right here. You guys see that? STO. And what letter is this? Well, you can use K. I want to use K. I'm very particular about trying to keep my letters the same. So, you just press alpha, and then right here, the parenthesis, you got that green little K there, right? And then now, every time I type in a K, it will use that entire thing, okay? And so now we're ready to go. Now we're ready to answer the questions they want us to figure out. So part B, it says, what is the size of the colony after 2 days? So I want to know what my new population is going to be. I'm still starting with 1,000. And now it'll be e to the k, but what's t? 2. And I know it looks like, oh, how do I solve that? But we know what k is, right? So you're literally just going to type this in the calculator now. Oh, let me write this down in the notes. Store it into k right here. Okay? And so now you do 1,000 E, and then K times 2. So alpha K times 2. And there we are. Okay, that's a pretty darn nice number, right? 1440. If you start rounding, you might get like 13 or 14, 38 point whatever, and then you're not as accurate. So it is important that we use that store feature. Otherwise, I mean, if you forget how, you can just write out all the decimals and then type them all in. But that's, yeah, it just takes a little bit longer. Okay? Any questions on that? Okay, why don't you guys try C on your own? Let's take a look. Where's your natural log of 6/5? Oh, this is from the previous problem.
Oh.
You got to do that, right? So try it again. So first figure out this, store it, and then it should work.
How did you get the K? I got it up here, but I can't get it into the
Same thing. Just press alpha, and then K is right there.
I tried doing that and no one can have parentheses.
Maybe you just forgot to press alpha.
Okay, it says it's southern alpha or it doesn't?
Just alpha, and then the letter.
Okay.
Yep.
Alright.
Okay, again, I'm slowly going to start writing my work up here. You can check if you're done, or if you want a checkpoint, look up. So if you've done things right, you should get to a point where you're doing natural log of 50 divided by K. We've stored it, right? So it's not a big deal. We just type that in. Natural log 50 divided by K. And so now we're getting about, what unit of time are we in here? Days? So about 21.46 days. Okay? Any questions on that? Nope. Okay. One more problem, guys, and then we're done with notes for the unit, and then you'll have some time. Maybe you can get the packet, because I'm probably going to trim those problems too. We're not going to do all the practice problems in the packet, and that's going to be your homework. Okay? Last example is half-life applications. Okay? So here we have a radioactive substance. This also applies with like medications. I think we might have talked about this earlier, but like if you take Advil or if you take antibiotic or whatever, that decays in your body. So after a certain amount of time, there's less and less and less, and they use this kind of stuff to figure out when it's safe to dose again. Because you don't, for example, you're not going to take Advil every 2 hours, okay? Because that's a problem. I think it's usually 6. It's supposed to be 6, yeah. But they've established that that's when it's safe because it's, the amount of medication in your system is low enough. Yeah, what does it say?
Look at there. What does it say? I literally just took it right now.
Okay, I'll come back to you. I think it's underneath the label, yeah. Okay, so let's finish this problem up. I'm still going to use the same growth law, you guys. Even though it's not like number of people or number of insects or whatever. So what is the starting amount here? 60 grams. So 60 e to the kt equals p. Here's my model. Okay? And now, just like before, they should give us enough information that I can go and figure out what that growth or decay constant is. Well, what do I know? Right here, the half-life is 1,690 years. Do you guys know what half-life means? Yeah, so
when it's halfway gone.
yeah, so half-life is how long it takes for there to be half. Does that make sense? So after 1,690 years, if we start with 60, how many grams are left? 30, half of it, yeah. Does that make sense? So half-life, length of time required for initial amount to be cut in half. Okay? If you can at least remember that, I mean, it's the same process as before. Okay, so when I set up my problem, 30 grams is left after how long? 1,690 years. Does that make sense? Divide by 60. So 1/2 equals e to the, and I'm going to put the 1690 in front just to make it a little nicer. Now what? Natural log of 1/2 equals 1690k. Divide by 1690. And then store that, right? Because that's k right here. Whatever that is, whatever those nasty decimals are, we're going to store that in the calculator. So natural log of 1/2 divided by 1690. Okay, it's very tiny. That's fine. Store it. There it is. Okay, and now we can answer the question they ultimately want us to figure out, which is how much is present 550 years later. Okay, so now what's my equation that I have to solve? Well, what is P? Oh, that's what we're finding. Sorry. P is going to be 60 times e to the k, which we now have, and then our time is 550, so we just type that in. So how much is present? 60 e to the k, whoops, not x, k times 550. Are you guys all getting about 47.88? Okay? This is the extent of applications that you need to be comfortable with. The growth law or decay law, it's the same equation. It's just plugging in, setting it up, solving, and that's it. Okay?